All right, Algebra 1, Lesson 5. We're going to talk about finding absolute value and adding real numbers. Hopefully this is still stuff that you're familiar with, it's still review. We should know, hopefully, a little bit about absolute value. Well, I mean, you can see it up here. The absolute value of a number is the distance from the number to 0 on a number line. Absolute value of 4 is written as our absolute value symbol, 4, close absolute value symbol. And if there's another name for that, I could probably take a look and see if it actually gives you any names for those bars. But that's what it's going to look like. Okay. What happens whenever I put a negative number inside those absolute value bars? What do I get? I get a positive number every time, right? Right. I'm not going to get, if it's -5, am I going to get 4? No. Okay. All right. Just making sure. Just want to make sure that the answer didn't always come out as 4, right? And that we understand that. And essentially what absolute value is doing is that it's giving you a measurement of distance, okay? And distance is always positive. So anytime I see those absolute value bars, in the end I'm talking about positive things. So we do have, later on, we'll deal with, interesting instances where, let's say we had the absolute value of x minus 5 equals -3. Can I solve that? Is that solvable? Why not, Clayton? Okay, that's fine. Anybody know why that's unsolvable? Well, we have absolute value sign. What does an absolute value have to equal? It has to equal a positive value, right? So to say that the absolute value of x minus 5 equals -3 is impossible, right? No matter what I do, I can't make that absolute value equal something that's negative. Now, it doesn't mean that x can't be a negative number, right? If I come over here and I just change this to 3, right, I have actually 2 solutions to any question like that, because x could be positive, x could be negative, right? Anything that's going to give me that type of answer. But an absolute value cannot equal a negative number, and that's my point, okay? Absolute values will always equal positive values, okay? All right, so in this instance, we can talk about the absolute value of 4, and we can talk about the absolute value of -4. Here on the left in blue, right, we're looking at the absolute value of -4, and we're talking about the distance that -4 is from 0. Well, it's 4 from 0, okay, so its value is 4. The absolute value of +4 has the same distance from 4 to 0 as -4 does, right? So its distance, or its value, is 4. So the absolute value of a number, let's say n, for instance, just as a variable, we could plug anything in, is the distance from that number to 0 on a number line, whether it's positive or negative, okay? Whether it's a decimal or a fraction, right? Can I put decimals and fractions on a number line? Yes, yeah, we can. Okay, so it's not always just whole numbers. Okay, we can use fractions and decimals, okay? That's why it said we're talking about real numbers. Okay, the sum of 2 numbers can also be found using the rules for adding real numbers. So here's where we kind of take another step, but these rules apply to all real number add-ins. So we have basically 2 rules. Rules for adding numbers with the same sign, all right? So like adding 2 negative numbers or adding 2 positive numbers. Okay, people still kind of struggle with this, okay? Especially whenever it concerns a positive and a negative. Or even a negative and a negative. Basically, anytime we deal with numbers that include negatives, people's brains just freak out. Okay, if you can see things on a number line in your head or even written out, it's going to help you understand negative numbers a whole lot better. All right, so to add numbers with the same sign, we add their, and this is really, really important, we add their absolute values. Okay? Add their absolute values. the sum will have the same sign as the add-ins. Remember, in this case, we're talking about positive and positive or negative and negative. Now, the one that nobody in here should have a problem with is adding positives and positives, right? 3 plus 4 is 7. 15 plus 9 is 24. Like, we could do that all day long, right? Okay, but whenever we're adding two negative numbers, I see people not just say algebra 1, but algebra 2, geometry, algebra 3, still struggle to get their heads wrapped around whenever I'm adding two negative numbers, the number is getting bigger in the negative direction. I'm going further to the left on the number line. So negative 3 plus negative 2, it's not 1, okay? It's negative 5. I went from negative 3, I continued to go negative another 2, I'm at negative 5. Does that make sense? Can we wobble our heads up and down, right? Or do we still kind of struggle with that? Okay, so even if you don't understand it number line wise, you should be able to look at this and say, okay, the absolute value of negative 3 is 3, correct? The absolute value of negative 2 is 2. What's 3 plus 2? 5. And the sign of the two things that I'm adding together is negative, so my answer is going to be negative. Does that help? Okay, well, let's go based upon that. Let's go, we're going to add the absolute values of the two negative numbers. So we got 3 and 2, and we understand that that's 5. And because they're two negative numbers, our number is going to stay negative. Okay? All right. Let's see. And then adding numbers with different signs. In this case, there's really only one scenario. That's adding a positive and a negative number together. So to add numbers with different signs, we want to find the difference of the absolute values. Okay, so in this instance down here, what's the absolute value of 3? What's the absolute value of negative 2? 2. So take 3 minus 2. What do you get? 1. So you're going to take the largest absolute value, you're going to subtract the smaller absolute value, the number that you get. Now the sign that you get goes with the add-in that is bigger. So if the negative is bigger, then your answer is negative. You follow me? Right? If the positive has a bigger absolute value, then the answer remains positive. Okay? Now, in a case like example, 3 plus negative 2, right? What is that the same as? Can anybody tell me how I could rewrite that statement, something that maybe even like we would work with all the time anyway? I mean, we don't typically say negative 2 plus 3, but do we ever say, let's say we dropped off the plus, right? What would the statement be? No, wouldn't be, that's not what I'm looking for. 3 minus 2, right? Isn't 3 plus negative 2 the same as 3 minus 2? Yes? So sometimes, especially if my positive add-in is bigger, it may be easier for you just to see that as 3 minus 2, right? Would I get the same answer? Yeah, I still get 1. All right, what does kind of give us a little bit of trouble is whenever our negative value is bigger. But the absolute value of 3 minus the absolute value of 2, okay, is still 1, okay, but because the negative is bigger, the negative goes with my solution. Okay, do we understand these two rules? Okay, all right, good. All right, and that's it for that. Let's try to work out some questions. Okay, let's see what we can do here. Let's see, you guys are out of here at 48, so we got about 5 minutes. All right, what's the absolute value of negative 2? Positive 2, okay, so we'd get C for an answer there. Okay, good. All right, let's find a sum of negative 32 plus negative 18. All right, those are two values with the same sign, so we'd go to our first rule, correct? Okay, which tells me that I'm going to take the absolute value of those two numbers and add them together, correct? So the absolute value of negative 32 is? The absolute value of negative 18 is? All right, what's 32 plus 18? 50, okay? Is my answer going to be positive or negative? Negative. Why negative? Because my add-ins are negative, okay? All right, I always try to work with money in this stuff. If you owe me $32 and now you owe me an additional $18, how much money do you owe me? You owe me $50. You know what you are? You're $50 in the hole. Okay, does that make sense? You're further negative than you were before. All right, let's look at this. Find the sum, this is mixing two things here, of 0.29 and negative 1.85. So this is mixed, all right? So this is rule number 2. What do? I find, do you guys still have your notes up? Okay, find rule number 2. Read it off to me. Yep, numbers with different signs. Tell me what it says. Find the differences of the absolute values, correct? And then my solution takes the sign of what?
Greater absolute value.
All right, which one of these has the greater absolute value? 0.29 or negative 1.85? Okay, so what we want to do is we want to find the difference. So we've got 1.85. You told me that's the absolute value. Difference means what? Subtract. So 1.85 minus 0.29. Is that right? Okay. Let's see. 5 minus 9 means I'm going to have to borrow. All right. What's 15 minus 9? 6. What's 7 minus 2? 5. Okay. And then I bring down to 1. My answer, is it going to be positive or negative? Negative. Why? Because the larger of the two absolute values was negative, right? So we should get that right there. How are we doing so far? Pretty good? Okay, is this starting to help out a little bit? Okay. Let's see. Let's look at question number 4. Let me look at my answer sheet here. Nope, wrong thing. Okay. Is this set of irrational numbers closed over addition? I'm going to go ahead and give you the answer on this. The answer is C. No, the set of irrational numbers is not closed over addition. For example, the sum of radical 5 plus negative radical 5 is not an irrational number. What is radical 5 plus negative radical 5? 0, right? They cancel out. They're additive inverses. Okay? But 0 is not an irrational number, correct? Okay, so that's why it's not closed. Okay, irrational number is not closed over addition, meaning that an irrational number plus an irrational number is not always an irrational number. Okay, so your answer to 4 is C. All right, let's try to cover at least one more, number 5. Or actually, here's what I'll do. I'll open it up to you guys. You guys can look through 5 through 12 and pick a question that you want to cover before we close up. Take a quick look. The faster you find one, the first one to speak up is the one that we'll do. Yep, go ahead.
7.
Number 7. Okay? Good question. All right, so basically what this is saying, if I can help you out here, is this is negative 1 times the absolute value of 13 minus 18. Okay? Absolute value symbols are another type of grouping symbol, which means what is the first thing that I should do? Simplify my grouping symbol, right? So what's 13 minus 18? Negative 5. Okay. So I have negative 1 times the absolute value of negative 5. What is the absolute value of negative 5? 5. So basically now, whenever I go ahead and take the absolute value, now it becomes this. Okay, negative 1 times 5, right? Because the absolute value of negative 5 is 5, and I want to continue to show that it's multiplication. Okay, what's negative 1 times 5? Negative 5. Okay, so that's a good question because it involves an instance where I do wind up with a negative answer, but my absolute value isn't negative. Okay, all right. That's where I'll stop, but you guys can work on your homework. Again, remember that your test will come from these questions that you see. So anything that you want to work on, I highly suggest taking a look, looking at the answers, practicing.